So welcome student. This is another class of the basic concept of a chemistry class. Okay. So in this class we will read the laws of chemical combinations. Okay. So in this chemical combinations, laws of chemical combinations, we will read law of conservation of mass, law of constant or definite proportions, law of multiple proportions, law of reciprocal proportions, okay, then Gay-Lussac's law of gaseous volume, and all the laws are actually what given by different scientists. So in chemistry we should appreciate the name of the scientist name, yes or no, because all these great scientists they given all the important concept of chemistry. Okay, so for their dedication we are reading chemistry. So first is law of conservation of mass, and we remember in this part laws means definition, statement, and then numerical question will come. Clear? So first is law of conservation of mass. Law of conservation of mass was given by Anthony Lavoisier. Law of constant or definite proportion was given by Joseph Proust. Law of multiple proportion was given by Dalton. Law of reciprocal proportion was given by scientist Richter, and Gay-Lussac's, this is a scientist name. Clear? So first we will read what is law of conservation of mass. You know, earlier you have read the mass can neither be created nor be destroyed. The mass can neither be created nor be destroyed. Similarly, what is the law of conservation of mass? So this is one statement. Another statement also we read in chemistry. The total mass of the reactant side is always equal to total mass of the product side. Clear? Total mass of the reactant side is always equal to the total mass of the product side during a chemical reaction. Suppose one example, carbon when combined with oxygen gives rise to CO2 gas. Okay, so what is the mass of carbon? 12 gram. Mass of oxygen 32 gram. What is the total mass in the reactant side? 32 plus 12 equals to 44 gram. Okay, what is the mass of CO2? So mass of CO2 is also 44 gram. Hence, the mass of the reactant side always equals to mass of the product side. Clear? Similarly, suppose another example. H2 plus I2 gives rise to 2Hi. So what is the mass of H2? 2. I2 mass 254 gram. Okay, Hi mass 2 into 127. So what is the mass of the reactant side? So mass of the reactant side equals to 256 gram. So here also, yes or no? It is 2 into 128. This is so equals to 256 gram. So mass of the reactant equals to mass of the product. Hence, the total mass of the reactant side is always equal to total mass of the product. Clear now? So this is the in chemical reaction you will remember. But in a nuclear reaction, the mass of the reactant side never equals to mass of the product side. Always the mass of the reactant side is greater than product side. Why? Because product side whatever mass decreases, that mass decrease mass that converted into energy, that according to Einstein equation E equals to mc square. That part you will read in physics. Clear? So in chemistry, in chemical reaction, the mass of the reactant side is always equal to mass of the product side. Okay, so this is the first law, law of conservation of mass, which was given by scientist Anthony Lavoisier. Then second is law of constant or definite proportions. Okay, law of constant or definite proportion, which was given by scientist Joseph Proust. Now see, what is the law? You know, because this part in the beginning part you have read in class 9. So what is the law? the law states that a chemical compound is always formed. A chemical compound is always formed from its constituent element, yes or no, in a fixed proportion by mass. Again, a chemical compound is always formed from its constituent elements or atoms or molecules in a fixed proportion by mass. This is called a law of a constant or definite proportion. Suppose if we take one example, formation of carbon dioxide, CO2. So formation of carbon dioxide, that means it can be formed by different processes, like carbon when combined with oxygen gives rise to CO2, combination reaction. So what is the percentage ratio? What is the mass percentage? So mass percentage equals to 12:32. 12:32. Or if you take 4 as a common, or 3:8. Clear? Similarly, suppose if you take another example, decomposition of calcium carbonate. So decomposition of calcium carbonate gives calcium oxide plus CO2. So here also carbon is to oxygen equals to 12:32 or 3:8. So this is also same. Yes or no? Similarly, if you will take Na2CO3, when it reacts with HCl, it gives rise to 2 molecules of NaCl plus CO2 plus water. So here also carbon is to oxygen mass ratio is same 12:32. So it is automatically it will come, because it is a theoretical question, means always during the formation of carbon dioxide, always carbon is to oxygen mass ratio will be 12:32 or 3:8. It is always true theoretically. But here I have written 2 numericals, okay, because the important part is numerical. So in the numerical part, how can you solve that? You see, 6.488 gram of Pp combined directly with 1.002 gram of oxygen to form lead peroxide. It is also produced by heating lead nitrate, and it was found that the percentage of oxygen present in lead peroxide is 13.38. Use this data to illustrate the law of constant composition or definite proportion. So how can you solve this? You see. So first question answer. So total how many experiment? 2 experiment given. So first experiment and second experiment. In the second experiment it is given the percentage of oxygen equals to 13.88. Now if in the first experiment, if you can calculate the percentage of oxygen equals to 13.88, hence it obeys law of constant or definite proportion. Yes or no? So now see, Pb combine with oxygen to form Pb lead peroxide. How much gram of Pb? 6.488 gram of Pb when combined with oxygen. How much? 1.002. So this much given. So how much amount of product will form? So according to previous law, so we will add this 7 point, yes or no? 7 point how much? 50, 7.90, 7.490. Clear now? So when Pb when combined with oxygen to form this much, yes or no? Clear now? So now we have to justify this law obeys definite proportions. This law obeys definite proportions. Clear now? See. So when PbO2 is 7.49 gram, what is oxygen? So oxygen equals to 1.002. When it is 1 gram, it is how much? 1.002 by 7.49. When it is 100, it is how much? 1.002 by 7.49 into 100 equals to 13.88. So in the first experiment, percentage of oxygen equals to 13.88. In the second experiment, data given also 13.88. Hence, so you see, there are two types of reaction. There are two types of experiment. So in the first experiment, percentage of oxygen is 13.88, and in the second experiment also percentage of oxygen equals to 13.88. That means it obeys which law? Law of constant or definite proportions. Understood? Clear? Okay, so this is the first question answer. Now come to second question. Second question also same given format. Experiment 1, 2.16 gram of copper metal when treated with nitric acid followed by ignition of the nitrate give this much gram of copper oxide. In the second experiment, 1.15 gram of copper oxide on reduction with hydrogen gas, yes or no, 0.92 gram of copper. So this data to illustrate the law of definite proportions. So here second question answer. So first one is experiment 1 and another one is experiment 2. So in experiment 1, how much gram of copper? So copper is 2.16 gram. When treated with nitric acid followed by ignition, the nitrate gave how much gram of copper oxide? So copper oxide mass is 2.70. Experiment 1. Experiment 2, what is the copper oxide mass? Copper oxide mass is 1.15 gram. With hydrogen gas, what is the mass of copper given? Copper given 0.92 gram. You have to justify this. This data of law of definite proportions. Clear? Now see, so here copper is 2.16, copper oxide is 2.70. So what is oxygen? Subtract them. 2.70 minus 2.16 equals to 0.54 gram oxygen. Here oxygen equals to 1.15 minus point how much? 23 gram. Now here you can calculate percentage of copper equals to how much. So you see, when copper oxide is like this, when copper oxide is 2.7, copper is how much? 2.16. So when it is 1, it is 2.16 by 2.7. When it is 100, 2.16 by 2.7 into 100. Okay. So this data if you divide, then it will come how much? It will come 80%. So if copper is 80%, so what is the oxygen? So oxygen equals to 20%. Clear now? Similarly here, when copper oxide is 1.15 gram, copper is how much? 0.92 gram. When it is 1, it is how much? 0.92 by 1.15. When it is 100, so it is 0.92 by 1.15 into 100 equals to how much? This is also 80. So oxygen equals to 20%. Clear now? So in this format you see both experiment 1 and experiment 2, the copper mass ratio is also same, oxygen mass ratio is also same. So this is called the law of definite proportions. Clear? See this. Check. Okay, clear now? Then, what are the limitations of this law? What are the limitations of law of constant or definite proportions? So, what are the limitations you see? First, this law is not applicable if the element have different isotopes. If the element have different isotopes, this law is not applicable. Clear? Second one is, if suppose different elements they combine in fixed proportion, but their formation of compound will be different. Suppose you see carbon is to hydrogen is to oxygen. Carbon, hydrogen, oxygen. Suppose it is 1:2:3 or 1:2:1. That means its compound will be C6H12O6. C6H12O6. So here ratio will be different or ratio will be same, compound formation will be different. That means suppose in this compound, suppose glucose, carbon 72, hydrogen 12, oxygen 96. Oxygen 96. Okay, so when their ratio will be same, the compound formation will be different. So glucose same ratio, ethyl alcohol also same ratio. So that's why there are two limitations. One limitation is this is not applicable for the element having different isotopes. Second, the compounds, yes or no, may be different compound, but they fixed in same what, combine in fixed proportion. Clear now? So like this in this part, theory and what, numerical part will come. Clear now? Okay.